Did you know that you don't need a GPS to navigate with coordinates? Keep watching and I'll show you how.
Before we get started, make sure to pick up a starter pack from hardballmaps.com where we're having a 10% off sale for new customers. This pack has everything you need to follow along with this course. So what are we going to learn in this course? We're going to learn about our equipment. We're going to learn what declination is and how to use it. We're going to learn how to plot coordinates or plot points. We're going to learn how to measure distance on the map and on ground. We're going to learn how to plan our routes, and we're going to learn how to do resection and intersection, which are forms of triangulation. Okay, let's quickly talk about our equipment. Here we have our Lensatic compass. It's called a Lensatic compass because it has a lens here that you use to find your degree. What you then do is shoot an azimuth using the wire and this notch on the top. An azimuth is just a line to where you want to go. So you find your degree, say we want to go at 90 degrees. We'll line up this notch with the wire and shoot an azimuth towards an object that's in our path. That helps us just stay aligned when we're traveling towards our point. And also while we're traveling towards our point, we can keep our compass aligned in the direction we're traveling, and we can move one of these yellow lines over the north-facing arrow so that if we get off track, that line will no longer be on the north-facing arrow, and we know that we need to shoot our azimuth again to get back on track. Here we have our protractor. You can see that there's two rings on the outside. The outermost numbers are mils. We will not be using those in this course. We'll be using the innermost numbers, which are degrees. You've got black numbers and red numbers. The black numbers are the degree. The red numbers are the back azimuth, which is just the opposite direction. So if you have a 90-degree mark, the back azimuth from that is going to be 270 degrees, which is on this side. You'll see that you have three triangles. These are for plotting coordinates. They're all for different scales. So the scale of your map determines which triangle you use. In this tutorial, we'll be using this triangle, which is the 1 in 50,000 meter, 1 in 50,000 scale triangle. These are called ranger beads. These are for tracking how far you've gone in the field. These beads are for 100 meters. These beads are for a kilometer. Since each kilometer is 1,000 meters, and each one of these represent 100 meters, every time you go 100 meters, you can move a bead down. And once all the beads are down, that means you've gone a kilometer, so you can move them back up and move one of the 1 kilometer beads down. Once you've gone through all 4 of the 1 kilometer beads, you can actually use the 100 meter beads to track a 5th kilometer. So these ranger beads, these can go up to 5 kilometers. Another good thing to have is an all-weather notebook. This is not in the starter pack, but I would highly suggest buying one of these because if you go out into the field and you're doing land navigation and say you fall in some water or it rains or you're going through snow and your notebook gets wet, if it's not an all-weather notebook, all of your notes, all of your coordinates, all of your azimuths, they're going to get wiped away and you're going to get lost because you aren't going to know where your points are. So make sure to pick one of these up in the shop while you're picking up the starter pack. A small but important part is a fine point pen. You're going to want a fine point pen because you're going to want to mark your coordinates as accurately as possible. For this starter pack, I've included a fine point permanent marker because our map is laminated. So you can actually go in, put a mark on there, get anything with alcohol in it, could be baby wipes, could be alcohol, medical alcohol pads, put a little alcohol on it, and that comes right off. So let's talk about this map next. We're going to briefly talk about map reading. So this is a laminated map. This is the same map that we'll be using in the course, and this does come in the starter pack so you can follow along. On the outside, you've got your latitude and longitude numbers. These are going to help us find our grid squares and thus plot coordinates. Here you have the name of the map. You've got the map zone, the scales, the map scale, which is 1 in 50,000, very important to pay attention to this, and the declination diagram. This declination diagram is going to help us convert from a magnetic north to a true north when we're going from using the map to using our compass, and I'll show you how to do that later. We're going to briefly go over some things on this map. Clearly, green means that there's vegetation. Black is anything man-made, so you've got your buildings up here, you've got your roads. And then I want to briefly explain contour lines. Contour lines are these reddish brown lines that kind of look like the inside of a tree. Just remember the highest points are going to be circled, and each contour line, 1, 2, 3, 4, you see these? Each one of those represent 20 meters of elevation change. So elevation change could be going up or it could be going down. Easy way to figure out which way is down is just go away from these circles, go away from the circled high points. All right, we're gonna quickly talk about terrain features. I want you to take your hand and make a fist, okay? So imagine that each one of these knuckles are hilltops. In between them, if you've got two hilltops, that space in between is called a saddle. Multiple hilltops in a row is called a ridge. Imagine that you've got the side of a mountain and you've got these high points with little depressions in between. These high points are gonna be called spurs, and in between is gonna be called a draw. This would be called a cliff. All right, so let's plot some points. Take out your all-weather notebook and your protractor. So whenever we're plotting points, I want you to think X, then Y. Okay, so I'm gonna give you a coordinate. It's gonna be an 8-digit grid coordinate, 18 STK. That is just our map zone. And our first coordinate is gonna be 8, 8, 4, 6, 10, 5, 4. First thing you're gonna do is draw a line down the middle, in between the 4th and the 5th digits. Then I want you to put an X on the left side and a Y on the right side. So these are gonna be your X coordinates and these are gonna be your Y coordinates. First thing we're gonna do is find the grid square, which is one of these squares here, so that we can plot our coordinate. So I want you to underline the first digits of each section. So we have 8, 8, and 10. Remember, this is our X and this is our Y. On our latitude and longitude lines, this is our X and this is our Y. So we're gonna find 8, 8 on our X axis, so our horizontal axis. So this is 8, 8, and we're gonna find 10, and this is 10. So we're gonna find where these two lines meet. They meet right here, all right? And the grid square is always gonna be to the top right. So this is our grid square. We found 8, 8, and we found 10, found where they intersected, and this is gonna be our grid square. Next, we're gonna plot our point. So we're gonna use the second two digits in each section. So 4, 6, and 5, 4. And for this step, we're gonna use our protractor. Make sure that the letters are reading properly. If they're not, it means it's backwards. And we're gonna find the correct triangle for the scale. So for this map, we're gonna be using the 1 in 50,000 scale triangle. And we're gonna align the bottom right part of this triangle with the bottom left of the grid square. So we'll go ahead and line that up and make sure that it is as straight as possible. Now what we're gonna do is we're gonna plot our X, which is 4, 6, with the protractor. So you can see here, you've got an X-axis and a Y-axis. We're gonna move the X-axis so that 4, 6 aligns with the bottom left corner of our grid square. So we'll move this until we get 4, 6. And you see here, we've got 10, 20, 30, 40, 45, and a little bit to the left of that is 46. So we've aligned our X with the bottom left corner of the grid square. Now, we're gonna plot our Y, which is 54. You do not have to move the protractor again. All you have to do is go up the Y-axis to 54. So 5, 55, and a little bit under that's gonna be 54. So take your fine point pen, and you're gonna put a mark right there. Just a tiny dot is all you need. You're gonna circle it and number it. We'll number this one 1. And that's it. That's how you plot points. All right, so now we're gonna draw azimuths. And remember, azimuths are just the direction from one point to the next. The direction of a line from point 1 to point 2. So for practice, I'm gonna draw another point here. We'll just make it up. I'll put a point right here. We'll call that point 2. Okay, so say I want to know the direction from point 1 to point 2. Well, we're going to take out our protractor, and the way I like to do this is tear out a piece of paper, and this is going to help us as like a ruler. So I will line up this small hole in the middle of the protractor with the starting point. So in this case, we're going to be going from 1 to 2. And I'm going to make sure that these crosshairs are as straight with the grid lines as possible. All right. It's kind of hard to see because it's in the middle of the letters here, but point 2 is right here. So I'm going to take this piece of paper, I'm going to slip it underneath the protractor and line it up as accurately as possible with these 2 points. All right, so it's lined up with point 1 and point 2. And I'm going to go over here to where the paper intersects the degrees, and I'm going to find the degree that it takes to get from point 1 to point 2. And in this case, remember we're using these inside numbers, not the outside numbers. The inside black numbers, and it looks like that's 40, 41, 42. So 42 degrees. I'm going to take the protractor off, I'll hold my paper in place. Remember 42 degrees, and I'm going to draw a line from point 1 to point 2. All right, I'm going to take out my all-weather notebook again. We said that that was 42 degrees. So this is 42 degrees, and this is going to be called a grid azimuth. Why? Because we just use the map to find the degree. If we wanted to go from point 1 to point 2, we would have to find the magnetic azimuth because we would be using our compass. Remember that there is grid and there's magnetic azimuths. For grid, you can only use the map. If you want to use the compass, you have to find the magnetic azimuth. So how do we do that? Remember earlier we talked about our declination diagram? This is the declination diagram. So if we're going from grid to magnetic, we're going to add the declination. And this is the declination right here, 10.7 degrees. Don't use negative 10.7 degrees. That's just showing that 10.7 is to the west of true north. So just treat this as a positive 10.7, okay? Positive 10.7. So we're going to get from grid to magnetic, add 10.7. So that would just be 42 degrees, because this is our grid, plus the declination, which is 10.7, which equals 52.7 degrees magnetic. And that's it. And you could round this up to 53, and we will do that, and we'll go ahead and write 53 degrees magnetic from point 1 to point 2. And that's how you draw azimuths and convert from grid to magnetic. So let's talk a little bit more on converting azimuths. Declination, as in the declination diagram, all declination is the difference between magnetic north and true north. Declination varies on your location. And you can see here that in North America, the western half of the country is an easterly declination, and the easterly half is a western declination. This map is from Pennsylvania, which is in the eastern half of the US, so we have a westerly declination. That's why our magnetic azimuth is represented by this arrow to the west of true north. Your location and your direction of your declination changes your conversion formula to convert from grid to magnetic and magnetic to grid. Since we have a westerly declination, we're going to add to convert from grid to magnetic, and we're going to subtract to go from magnetic to grid. All right, so let's talk about measuring distance on the map. Let's pretend that we want to go from point 1 to point 2, and we want to know how far we have to travel. Take out a piece of scrap paper, put a tick mark at point 1 and a tick mark at point 2. Bring it down to your scale. Make sure that you're using the kilometer scale and line up that first tick mark with 0, okay? And then we'll mark the 2 kilometer part, okay? So this is 1 kilometer, 2 kilometers. We'll write 2 km. There is a little bit of difference, so we'll take this down to subdivided section. Since 1 kilometer is 1,000 meters, each one of these squares is divided up into 100 meters. So I'll say that this is probably another 100 meters there. So I'll put 100 meters. So now we know that our distance is 2 kilometers plus 100 meters. Since a kilometer is 1,000 meters, we know that this is 0.1 kilometers. So our distance is going to be 2.1 kilometers. We'll bring this back up here and we'll write 2.1 km. So what if our distance wasn't in a straight line? Let's say that we wanted to navigate along a road. Let's pretend that we want to measure from this point to this point. We can again use a scrap piece of paper and use tick marks. So we'll start at this intersection. We'll put a tick mark right there. And we'll go to the first curve in the road. We'll say it's right here. So now we've got a tick mark for the first straight leg of the route. Now we'll pivot on this tick mark and try and keep it in the same spot until the next curve in our road, which will be right here. And we'll pivot again until we get to our intersection, and that'll be our next tick mark and our stopping point. So you can see that we've mapped or measured from this point to this point to this point to this point, which is our whole route. And now we're going to move down to our scale so we can measure this distance. So our first tick mark is going to go on 0. And this is our stopping point here. So I'll put an X. And we're going to measure out that first 2 kilometers. And from here to here isn't quite a kilometer yet. So I'm going to move down to the 0, and I'm going to count how many 100 meter sections we have between the 2 kilometer mark and our endpoint. So that's 1, 2, 3, 4, 5, maybe 5.5. So that's 550 meters. So we have 2.55 kilometers from here to here. And that's how you measure irregular distances.
So before you step off, you're going to need to know your pace count. Your pace count is the number of steps it takes you to go from 0 to 100 meters. So before you step off, mark off 100 meters and count how many steps it takes you to walk to the 100 meter mark.
So let's talk about route planning. It sounds simple. You know, if I wanted to go to the grocery store, I'd just walk along the road, on the sidewalk, go across the crosswalks, and eventually I'd be to the store, and I'd just go in the same direction or the same route to come back home. But when we're in land navigation or in an SHTF scenario, we can't always use roads. It might not be available to us. So we have to use a mixture of 2 methods. The first method is dead reckoning, which means just going in a straight line. For example, from point 1 to point 2, if we just went in a straight line like this, that would be called dead reckoning. The second method is called terrain association, and that essentially means using the terrain around you, like roads or hilltops or valleys or streams, to get to where you want to go. So for example, if we were to just go from this point, this intersection, to this intersection and walk along the road, we would be using the terrain to guide us, so that would be terrain association. You could also use a stream. You could walk along a stream, that would be terrain association. You could walk from one hilltop to the next hilltop, that would be terrain association as well. Now, you can mix these 2 methods together. So let's say I wanted to go from this intersection to this intersection and then get to a hilltop over there. There's no road going from this intersection to that hilltop. So what I could do is navigate along this road, and then I could use my compass to shoot an azimuth and then walk from this intersection to that hilltop. So you can see I'm using a mixture of terrain association to dead reckoning. So let's talk about searching methods really quick. Let's say we get to the area where our point is, but we can't quite find it. Well, here's what I do. I use the cloverleaf method. So let's say this is me, and I've walked the distance I'm supposed to walk at the correct azimuth, and I'm trying to find my point, but I don't quite see it. What I'll do is I'll maybe break a branch or drop my backpack, and I'll go in cloverleaf shapes, maybe 10 or 15 or 20 meters out in 360 degrees until I find my point. And it's really that simple. But make sure to mark where you start, or else you could really get off track. All right, so let's practice intersection. Intersection is just a word that we use to describe triangulation to find an unknown point, okay? So in order to triangulate to find an unknown point, we need to have two known points on our map, okay? So in this example, we're gonna be using two hilltops, point 1 and point 2. Whenever you're doing triangulation, you need a minimum of two known points. You could have 3, 4, 5. The more you have, the more accurate, but it's 2 at minimum. So let's pretend that we're on point 1 and that we're conducting maybe a reconnaissance or a search and rescue mission, and that we see someone out in the distance who's signaling for help, okay? So what we're gonna do is we're physically on point 1, this hilltop. We're gonna take out our Lensatic compass, and we're gonna use the lens notch in the wire to shoot an azimuth towards that unknown point, okay? And that azimuth, since we used our compass, is gonna be a magnetic azimuth. And for this scenario, we'll say that that azimuth from point 1 to our unknown point is gonna be 79 degrees magnetic. So remember I said before, we have to use grid on our map and magnetic with our compass. Well, we got this magnetic azimuth with our compass, and now we have to convert it to a grid azimuth so we can do triangulation on our map. How do we do that? With our declination diagram. Before, when we were getting our azimuths, we were converting from grid to magnetic. Well, now we have a magnetic azimuth that we want to use on our map, so we're gonna have to convert from magnetic to grid. So we have our magnetic azimuth, and to convert to grid, we're gonna have to subtract the declination. So we're going to subtract 10.7 degrees, which is our declination. This is our declination. 79 minus 10.7 is 68.3 degrees grid. And I always like to annotate grid on there. So 68.3 degrees grid. All right, so now we're going to physically move from point 1 to point 2, and we're going to, from that hilltop on point 2, shoot another azimuth towards our unknown point using our compass. All right, so we've shot that second azimuth, and we got 54 degrees magnetic. All right, so we want to convert this to a grid azimuth since we want to use it on our map. So we're going to go back down to the declination diagram. When we're converting from magnetic to grid, so we're going to subtract the declination. So 54 minus 10.7, which is our declination, just like we did up here, equals 43.3 degrees grid. All right. So we now have our two grid azimuths. So this was from point 1, right here, and this was from point 2, which is right here. And remember, you need at least two known points to do triangulation. The more, the better, but minimum, you need two. All right, so let's go ahead and draw these azimuths on our map. Okay, so we're gonna take out a protractor. We'll start with point 1. We will put that hole on point 1, and we're going to take out a straight edge and slip it under here. And since our grid azimuth was 68.3 degrees, let me zoom in here, we're going to line up this piece of paper with 0.1 and 63 degrees. Oh, I'm sorry, 68.3. I apologize, 68.3. So we'll just round that down to 68. 68 right there. All right, so 0.1, 68 degrees grid, we're good to go. So we'll take the protractor out, and all we do is draw a line out from 0.1, okay? Just like that. All right, so we shot an azimuth of 68 degrees grid from 0.1. Now we're gonna do from 0.2, 43 degrees grid. And we don't have to do the 0.3, that's pretty insignificant, so we'll shoot an azimuth of 43 degrees grid from 0.2. So again, we'll line up 0.2 with the middle of our protractor, make sure our crosshairs are lined up with our grid lines. We'll get another straight edge, and we're gonna do our grid azimuth of 43 degrees. So we'll line up the piece of paper with 0.2, and we'll find 43 degrees. And remember, we're using these inside black numbers, not the red number, not the number on the outside, the inside black number. All right, so we've got 43 degrees right there, got it lined up with 0.2. We're gonna pull the protractor out, pull the paper in place, and we're gonna draw a line out from 0.2. All right, so now you see that we have two lines. Where these lines intersect, that is the location of our unknown point. So if you want to find the coordinate of that, what you can do is first find the grid square, and remember that we do x before y, and we'll just do like plotting points but in reverse. So we'll find the grid square, which is going to be this grid square, and we said before the grid square is always up and to the left, or up and to the right. So this is where our latitude and longitude would intersect. So that's 89 for an x, we'll write 89, and 12 for a y. Okay, now we still need these two numbers. So we'll get our protractor out, align it to the bottom left of the grid square, and we'll move it to where that y-axis is right up on that intersection there. Okay, so that looks like maybe x first, so I know that's kind of hard to see, but that's a 7. So I'm thinking maybe 7, 9 for our x, 7, 9. And maybe that's 5, 10. So maybe 0, 9 for our y. All right. The 8-digit grid coordinate is 89791209. And that's how you find the location of an unknown point. Now we're going to be talking about resectioning. Resectioning is just another method of triangulation, but this time we're going to be using triangulation to find our own location. So let's pretend that we're lost and we can see 2 points, because you're going to need at least 2 known points on your map to find your location. Just like an intersection, now we needed 2 or more points. We can see 2 known points from where we are that are on our map. So we're going to use the same hilltops, 0.1 and 0.2. So we're going to take out our Lensatic compass, wherever we are, and we're going to shoot an azimuth towards our known points. So we'll shoot an azimuth towards mountaintop 1. And for that azimuth, we're going to get 66 degrees magnetic, since we used our compass. So we got 66 degrees magnetic. But we want to convert that to grid so that we can use our map to triangulate where we are. So we're going to be going from magnetic to grid, which is subtract declination. So 66 minus 10.7, and that equals 55.3 grid. All right, So now we've got our grid azimuth, but there's one more step we need to do in resectioning. We need to get the back azimuth. So since we're shooting an azimuth towards a point, we need to get the opposite direction of that azimuth so we can draw a line back from the known point to where we are. So 55.3 is less than 180. So we are going to add 180. So 55.3 plus 180 degrees equals 235.3 degrees, and that's grid. So we converted our magnetic azimuth to grid. We got 55.3. 55.3 is less than 180, so we added 180. If this number had been greater than 180, we would have subtracted it from 180, okay? So remember, we can write this on our map. It's less than or equal to 180 degrees equals add. Greater than 180 degrees equals subtract. And this is for finding your back azimuth, okay? So if you need to find a back azimuth, remember it's on your protractor in the red numbers, but if you need to calculate the back azimuth of a certain degree, if it is equal to or less than 180, you're going to add 180. If it's greater than 180, you're going to subtract 180, and that'll find the opposite direction from the degree that you're calculating, okay? All right, so we found our back azimuth from point 1. So this is point 1. All right, so we found that one. Now let's do point 2. So we're somewhere out here in the wilderness. We can see hilltop 1 and hilltop 2. We shot the azimuth and calculated the back azimuth for point 1. Now we're going to shoot the azimuth for point 2. So we'll take out our Lensatic compass, shoot the azimuth, and for this one, we get 87 degrees. So for point 2, 87 degrees magnetic. All right, now what do we need to do again? We're going from magnetic to grid, so we need to subtract declination. So 87 minus 10.7, which is declination. 87 minus 10.7 is 76.3 degrees grid. All right, and just like we did up here, we're going to need to find the back azimuth. So we're going to find the back azimuth of 76.3. 76.3 is less than 180, so we're going to add 180. So 76.3 degrees plus 180 degrees for the back azimuth equals 256.3 degrees. Grid. All right, so now we've got our two grid azimuths here that we can draw and find the intersection to find our own location. All right, so I'm going to zoom out just a tad here. All right, so first we're going to do point 1, which is a back azimuth of 235.3 degrees grid. So we will take out our protractor. This is point 1, so we're going to put it over point 1. And let me grab a piece of paper here. And we're going to find 235. We can forget the point 3. 235 degrees from point 1. So we'll slip our piece of paper under there. 235 from point 1. It's going to be right there. Okay, 235. So we'll keep our paper in place and we'll draw that line back. Okay. All right, point 2. Back azimuth of 256 degrees. Again, we can forget the point 3. It's very insignificant. So 256 degrees from point 2. Point 2, we'll get our straight edge and we'll find 256 degrees. 256 degrees, right about there. Remember, we're using the black numbers, not the red numbers, because we already calculated for a back azimuth. 256 degrees from point 2, it's right there. We'll draw our line. So now you can see that we've got an intersection right there. All right, so it looks like we're on a road here. So now we can go ahead and just find that coordinate like we did before. So we've got our 8 digits. We'll draw the line in the middle. We've got our X, we've got our Y. We'll find the coordinate, the grid square first. It looks like it's gonna be here in this grid square, just barely. So for our X, that's 86 and 10. So I'll write 86 and 10. Now we gotta find the second 2 digits for both sections. So we're gonna use our protractor. We're gonna position it to the bottom left of that grid square. All right, and we're just barely over here. I'm gonna call it right there. So for our X, we've probably got 9 right there on the bottom left part of the grid square. And then maybe right there, maybe a 0, 2. So 0, 9, 0, 2. 0, 9, 0, 2. All right, and that's gonna be our location for our resection portion. So I'm gonna show you all a trick to where you can check your own coordinates at home. You can do practice questions on your own. So go to Google, type in GIS Surfer. GIS Surfer, search. Click this first link, mappingsupport.com. Now scroll down, click View the Map Full Screen. Go to Menu. Go to the UTM USNG. Select MGRS Military. You can go and change to a world topo and go to search. All right. Now the first thing, this is where we're gonna type in our coordinate. The first thing you type in is the map section. So our map section is 18 STK, or 18 Sierra Tango Kilo. So go ahead and type in 18 STK. And then we can type in our 8-digit grid coordinate. So let's go ahead and type in that last coordinate we got for resectioning, which was 86091002. Okay, so we've got our coordinate in there. We'll make sure it's correct, and we'll click search and mark. And this will bring us to where we plotted our point. So we can check and see how accurately we conducted this resection and plotted that point. So you can see it's plotted right there on this Stanley Road next to the stream, right at that curve. So let's see where we plotted it on our map, and we'll see if we're accurate. So you see we've got this road here, Stanley Road, and it's plotted right here. This intersection is right on the curve of that road. So we can compare that to where the crosshair is. You see that crosshair on our GIS surfer compared to where we are on the map. That's pretty close, okay? And I'll show you what else I do with this GIS surfer web app. You see you've got the 8-digit coordinate up here in the corner. So what you can do if you want to practice plotting points is you can take a sticky note and you can just place it over that crosshair and scroll around and then plot this coordinate. And then whenever you've got your coordinate plotted on your map, you can take off this post-it note and you can compare where the crosshair is to where you plotted your point to see if you're accurate. All right, that concludes the course. I'll be uploading more practice videos with in-depth explanations in the future, so be sure to subscribe and hit the bell button to be notified of when that new content comes out. Thanks for watching, and I'll see you next time.